And now this lucky reporter will be the first human to sample this delicious crime against nature. Juicy, flavorful, with just a hint of...
Hey, that's my check cashing arm, you stupid! A little tip, you might want to wash me before you eat me.
Thank you.
The muncher's got Mo.
Well, we're not going out to help him. We have no idea what hideous creatures might be out there. Please let me in! How do I know you're not a muncher? I'm your father and I need your help. I can't make sense of that muncher talk.
So after having a look at the clip, you are now familiar with the plot, okay? So we are going to use, in this tutorial, we are going to use the SciPy module to predict the fate of humanity in case of a zombie outbreak. So the following model is taken from Phillips Morse et al. And he has defined these three differential equations whose parameters are defined as, so S is the number of people who are likely to get infected, Z are the number of people who are converted to zombie, that is the number of zombies, and R is the number of people removed or died by any natural cause or zombie attack. And we have taken a constant birth rate of B, okay? And alpha beta gamma here, alpha beta gamma denotes the rate for following, that alpha is the rate of killing of zombies. So you should keep in mind that zombies can only be killed by removing the infected area or by removing their heads, okay? We have to kill them very brutally, okay? So here beta signifies, so you can take a look at this code. Basically I have written it very smoothly here, rate of natural death and all. So you can have a look at this. After getting familiar with this theory part, we are going to jump to the coding now, okay? So here the special thing in this tutorial is that we are going to use the solve IVP module. So this solve IVP function is a very important function, as this gives us freedom to work with the ODEs in which predefined functions are given. Like we are going to define here the predefined function like B, D, delta and all, and initial population and all. So it is going to help us in that way. So we are going to start our coding by importing the SciPy, NumPy and Matplotlib modules, and especially SciPy.solveIPP. So after importing this, we are going to define the parameters like birth rate is 0.1, delta 0.01, which is the rate of cause of natural death, beta transmission coefficient, effectiveness of virus, gamma is the rate of human converting to zombies, and alpha rate of crushing their head or killing of zombies, okay? So in initial condition we have defined that the initial population was 1200. There is no population of zombie at the time of outbreak, that at t equals to 0, and no death. And we have denoted y0 vector, which is the initial condition vector. So after defining this, we have defined a model that he has defined, so we are converting it to a form that our PC could understand it, our Python could understand it. So we have defined a survival model in which t and y are taken, that is the initial parameters at any point of time and the time t. So si, zi are the parameters at any point of time in the given interval, and we have defined f0, f1 and f2, that is f1, f2 and f0, f1 and f2. We have defined it in this way. So this is not a very challenging task, you can do it very easily. This simple multiplication and minus and subtraction, okay? So in the end we are going to get a vector which is denotes a particular time instance, okay? At t equals to some 5 days, 10 days, okay? It is going to denote that. But we are here to plot a graph. So in that we have taken an interval of 300 days. We are supposing that the outbreak will last for 300 days. So we have taken t start to t end as 0, 300 respectively. And for the solution we have using solve IVP, I've discussed earlier. And we have defined our model. So we have giving the model input, time interval and the initial parameters. So we are going to plot the graph in this time frame, that is theta to t end, and we are taking 300 equally placed points. That is simply, you can say, one day. Okay, there is an interval of one day, frequency of one day we are using. Okay, so for plotting we are using plt.plot, that is matplotlib, and simple function. So after running all of this code, we are going to get a plot. So in this plot you can change the input days and all. Okay, so we can see at about 130 days there is population of people are going to be less than the zombies. So let's take a quick look at that. So we have defined ts to tn and 130, and the same function I have just copy pasted it from the above, but I have changed this unit. Okay, that 130 days, now we are taking 130 days. Okay, so we have to take here also 130. Okay, we have taken it. So after plotting its graph, oh sorry, we have to take it from above now, because there is a function in down there, so we are affecting by it. So here, after running all of this code, we can see that at 130 days we are getting an intersection point, after which the human population will be less than the zombies. So zombies are going to rule it. So we can see that the zombie population is going to saturate at 600, and the humans are going to die at about 150 days, 170 or 150 days. We are not going to be on the earth, but we are humans and we cannot let ourselves die in this scenario. Okay, we are going to try something. So in the second module we are discussing, we have introduced a new parameter called raw. Raw is the recovery constant, rate of recovery, that the people who are becoming zombies are going to become humans by fighting against the virus. So after defining raw, so what I have done is I have taken the above this one code, I've taken it and copied it down there. Okay, but with a little change, that is I have defined there a raw, which is the recovery constant, you can say, rate of recovery, and all of the parameters are same. Just have a look at this, that in the first equation, which signifies the number of people at a particular time, we have added z1 times raw, which is the number of people who are getting converted to the human form back, the number of zombies who are getting converted to humans, and there we have subtracted the same factor from the zombie population. Okay, so now after defining this, we will take a time stand again of 500 days and will plot the graph. So in this graph you can see that after about 130 days the curve was almost the same, but you can see after 300 days the population of humans rises or is greater than the population of zombie. The zombie have died at about 500 days, they are 0, and only humans have survived with a population of all about 200. So in this way we are able to survive this deadly zombie apocalypse. So great thanks to Netflix for bringing up this amazing documentary, the web series, I can say. And but wait, I guess something is coming. So there's a surprise for the next video, that we are going to be having a look at the Kepler's law. We are going to study the trajectory of planets, satellites and other asteroids. So stay tuned for that. Okay, another Netflix original is going to be on its way. Okay, so I think that's all. And if you want to have a look at, if you want to get this code, you can just refer to my GitHub and you can get this. So please try to make some changes in this code, play around with this and bring your own variation. Okay, so okay, now let's see you in the next video, I guess. Yeah, so thank you for watching.